Hello, in today's lecture we will learn about types and recursion. Built-in data types are types that are provided by default in Python. We have already learned about data types such as int, string, float, and bool. In addition to these, various data types exist in Python such as tuple and set. Today, we're going to learn about these built-in data types. As shown in the slide, built-in data types fall into different categories. Currently, you don't need to know every data type. Among them, today we will learn about list, tuple, dict, and set. We talked a little about the data type called list in the previous lecture. List is one of the data structures provided by Python. You can think of data structure as a structure that stores data in an organized way. Python has several built-in data structures. Today, we will learn about tuple, set, dictionary, and list among them. Tuple is a sequence in which certain values are stored using commas. A tuple can be created by using parentheses. In Python, you can also create tuples with one element. Try running the code at the top of the screen. According to what we learned, if we enclose data using parentheses, it becomes a tuple. But if we enter the code, we can see that a becomes an integer, not a tuple. This is because the Python interpreter regards the parentheses as parentheses used for operation. So when creating a tuple with a single element, you must put a comma after the element so that the Python interpreter can recognize it as a tuple with one element. So if you add a comma after one as shown below, the Python interpreter assigns a tuple to A. You can assign a tuple to a variable, but conversely, as shown in the slide, it is also possible to assign values in a tuple to several variables. The elements of a tuple can be accessed using a square bracket, just like the string type. The elements of tuple are stored sequentially at each index. For example, the elements of the new mat variable in the slide are stored in 3 spaces. The string mat is stored at index 0 and new mat1 stores 25. The last element is stored at index 2. Note that indices always start at 0 in Python. Like in strings, you cannot change the elements inside a tuple. For example, if you try to assign a new value to any index in the tuple, you will get an error as shown on the screen. However, it is possible to assign a new tuple to a variable. Tuples can be useful when a function needs to return multiple values at once. As the slide shows, we can return more than one value, and we can regard the return value as a tuple. Python provides a data structure called set. A set is a group of data with no duplicate values, which can be initialized using the set function or initialized using curly brackets. When creating an empty set, you must use the set function. This is because if you use empty curly braces, you will create another data structure called dictionary. Let's say you have a blog, and we want to identify unique visitors to this blog. Assuming that we have a Python list data of usernames of all visitors, let's think about how to exclude duplicate usernames. The easiest way is to put the visitor list data into the set function. This gives us a set of unique usernames. A set can contain a variety of data, and a tuple can also be put into a set. For example, if you put a duplicate tuple value into a set as shown in the slide, only one of this value exists in the set. To add a new element to a set, you can use the add method. For example, as shown in the slide, if you create a set A, you can add 1 to the set A through the code a.add1. And when you want to add multiple values to a set, you can use the method called update. If you want to delete any value among the values in the set, you can use the remove method. For example, if you want to delete the value 33 from set A with the value 33, you can call a.remove33. Therefore, if you print A after calling the remove method, an empty set will be printed. To check what values exist in a set, you can use the in and not in keywords. If you run the code in the slide, you can see how in and not in work. If you want to check the size of a set, you can use the len function. List is also a data structure. A list is an ordered set of values. However, unlike a set, a list can contain the same value repeatedly. And unlike a tuple, you can change the elements inside. Lists can be created using square brackets and commas, and the elements of the list can be any type. Of course, it is possible to put a list as an element in another list. Lists can be initialized in the following ways. To create an empty list, call the list function or use square brackets without any element. You can also put a list inside a list. Similarly, tuple can also be a list element. Elements of a list can be accessed using square brackets. The index starts from 0. For example, the string monkey exists at index 1 of the list variable animals. Like set, to count the number of elements in a list, you can use the len function. When you want to check whether a certain value exists in the list, you can use the in and not in keywords like set. A list is a mutable data type unlike strings and tuples. It is also possible to access an element of a list and then assign a new value to that index. For example, when there is a list called A, if you want to change the value at index 0 of this list, assign a new value to the index as shown in the slide. Let's look at the methods of list type. Append is a method that adds a new element to the end of a list. The list.insert method is a function that adds a new value to the specified index. For example, the code a.insert 2,10 means inserting the value 10 into index 2 of a list A. It is also possible to delete elements of a list. For example, if you want to delete the value at index 1 of the list A, you can use del a square brackets 1. Another data structure supported in Python is dictionary. A dictionary is a data structure that stores certain key and value pairs. A key in a dictionary must be unique. That is, there can be no duplicate keys. A dictionary can be initialized in a number of ways. First, if you want to create an empty dictionary, you can use curly braces as shown in the slide. When you put a new key value pair in the dictionary, just put the key in square brackets and assign the value to be paired. Any value in a dictionary can be accessed through a key. For example, if the key 1 and the value string A are stored in the dictionary A, to access the value A, you need to access the key 1 in A. A dictionary can also be created by calling a function called dict, parentheses. The dict function returns an empty dictionary. Keys in a dictionary must be unique. You cannot create two keys with the same value. Also, the key must be immutable type. For example, we learned that the internal elements of the string and tuple are immutable, and that these two data types are immutable. So string and tuple can be the keys of a dictionary. However, list is a mutable data type, so a list cannot be a key of dictionary. Of course, a dictionary is also a mutable data type, and a dictionary cannot be a key to another dictionary. In Python, you can use casting to change the type of a data structure. Enter the code shown in the slide into the Python shell. If you put a value of type int into the float function, the value is changed to a value of type float. And if you cast a bold type value of true using the int function, you get a value of 1. If you cast a bold type value of false using the int function, 0 will be returned. Finally, we can utilize the list function to turn a tuple into a list. For example, as shown in the slide, if we put a tuple with 3 strings as an argument to the list function, we can get a list data type. Last time, we learned that we can call functions inside functions. Among them, recursive function refers to a function that calls the same function itself. To help you understand, let's continue the explanation by seeing an example. Let's implement a function sum2n that returns the sum of natural numbers from 1 to n when a positive integer n is passed as an argument. No error handling code is required. For example, if you implement the code using what you have learned so far, you'll be able to implement a function using a loop as shown in the slide. However, we can implement this function like this. When you first see this function, it may feel strange, but the code will be easier to understand if you consider that the function is only executed when it is called. Let's see how it works by putting some values into the function. If you put 0 into the function checks the if condition and returns 0. Consider the case of putting 1 in the function. When 1 is passed to the function, the conditional expression is checked. And since n is greater than 0, the code in the else block is executed. This code returns 1 plus sum2n 0. Here, sum2n 0 is executed again to evaluate this expression. As you know, sum2n 0 returns 0. So after sum2n 0 is called, the expression is changed to 1 plus 0. And finally, sum2n 1 returns 1. Let's consider the case where the sum2n function is called with an argument 2. Because the value of n is 2 and the if condition is not satisfied, this code returns 1 plus sum2n 1. So the Python interpreter calls sum2n 1. And sum2n 1 returns 1 plus sum2n 0. So the return value of sum2n 2 is 2 plus 1 plus sum2n 0. Of course, sum2n 0 is called once again before this expression is evaluated. Finally, the expression turns into 2 plus 1 plus 0. Eventually, sum2n 2 will return 3. Consider the case where sum2n 5 is called. The return value is 5 plus sum2n 4. Here, sum2n 4 is called, which again returns 4 plus sum2n 3. So, sum2n 3 is called again. This function returns 3 plus sum2n 2. So another sum2n function is called, and finally the expression becomes 5 plus 4 plus 3 plus 2 plus 1 plus 0. If you want to write recursive functions without difficulty, you need to practice a lot. You don't need to be proficient in writing recursive functions right now. All you need to know is that you understand how recursive functions work. Let's solve some exercise problems. First, let's implement the function fibn that returns the nth Fibonacci number. the nth Fibonacci number is equal to the sum of n-2 Fibonacci number and n-1 Fibonacci number. Knowing the first two Fibonacci numbers, you can calculate all Fibonacci numbers. The first two Fibonacci numbers are 0 and 1. Implement the function fibn that returns the nth Fibonacci number. For example, we can implement the Fibonacci function in the following way. When n is 0 or 1, 0 or 1 would be returned. Otherwise, the sum of the previous two numbers is returned. If 0 or 1 is passed as an argument to the function, the conditional expression is checked and 0 or 1 is returned. If 3 is passed to the fib function as an argument, n is not 1 or 0, so fib2 plus fib1 is returned. So fib2 is called. Fib2 returns fib1 plus fib0. Fib1 returns 1, and fib0 returns 0. Finally, fib3 returns 2. When fib5 is called, the return value is calculated as follows. First, fib5 returns fib4 plus fib3. After that, fib4 is called, which returns fib3 plus fib2. After that, fib3 is called again, and fib2 plus fib1 is returned. After that, the function is called continuously until fib1 or fib0 returns 1 or 0. So finally, fib5 returns 5. Now, let's implement the function factn that returns a factorial of n. A factorial of n is a product of all natural numbers less than or equal to a natural number n. The factn function is a function that takes the natural number n and returns the factorial of n. Let's implement the function. For example, we can implement the code like this. When n is 1, 1 is returned. And if n is greater than 1, the product up to n-1 is multiplied by n and returned. Here, the product up to n-1 can be obtained by calling fact n-1. For example, if we put 1 into this function, we can get 1 through the conditional statement. Let's see how the return value is calculated when fact3 is called. First, fact3 returns the product of 3 and fact2. Therefore, fact2 is called for the evaluation of this expression, where fact2 returns the product of 2 times fact1. Fact1 is 1, so the final expression becomes 3 times 2 times 1, and 6 is returned. Fact5 is executed in a similar way. First, fact5 returns 5 times fact4. Fact4 returns 4 times fact3. In this way, the function is continuously called until fact1 is called, and finally, the function fact5 returns 5 times 4 times 3 times 2 times 1, with the return value of 120. This is all for today. Next time we will learn more about lists.